Okay, the bread and butter of probability trees. How do we draw them? They look something like this, and we're told to complete the table and complete the diagram. Okay, no matter what the probability is, the probability always has to be equal to 1. Okay, so this number plus 0.4 is equal to 1. So to work out the number in the blank, all it is 1 minus 0.4, which is equal to 0.6. Okay? And it's the same thing with these numbers here. Okay? In the second spinner, you got, I'm assuming that's blue is 0.2, purple is 0.4. So the probability of red is just going to be 1 minus 0.2 minus 0.4, which is equal to 0.4. Now, yes, of course it is here, but I'm just showing you if, let's say, you didn't know, it's going to be there, okay? We know that the second spinner is exactly the same, no matter what spinner 1 gives us, whether it gives us green or yellow. So, therefore, we know this probability is also going to be 0.2 and 0.4, okay? These two probability trees are the same because they've got the same spinner, okay? Now let's look at the table. If the probability of green is 0.6, we can see the probability of yellow is 0.4. And if we don't know that, then it's just going to be 1 minus 0.6. Same with the second spinner. We can see that the probability of blue is 0.2 and the probability of purple is 0.4. And that is how we craft our probability trees. Is this video helpful? Make sure you subscribe so you never miss a video from me. Now let's look at applying what we do know to a probability tree. Here are two spinners. We spin A and then we spin B. Complete the tree diagram. So, as you can see, for the first spinner, we see that there are 1, 2, 3, 4, 5, 6 faces, okay? 2 of them represent yellow, so it's a 2 in 6 chance of yellow or 1 in 3. There are 4 out of 6 blues, okay? Which is equal to 2 in 3, okay? That's how we put 2 and 3 into the tree diagram. Now let's look at number B, spinner B. Spinner B has 1, 2, 3, 4, 5, 6, 7, 8 faces, okay? 2 of them are yellow, so the probability of yellow is equal to 2 over 8, which simplifies to 1 in 4. I said in a previous video that you do not need to simplify if it's a probability. I'm just going to because I can see that the question simplifies. So I'm just going to follow suit. It's an exam technique thing. The probability of blue, right, is still going to be 1, 2, 3, 4, 5, 6 blue. So the answer is 6 over 8, or 3/4. And because these two are the same spinner, right? I don't know, you can't see this yellow. Because these two are the same spinner, means these two answers are both going to be 1 in 4 and 3 in 4 respectively, okay? Right. Now let's work out the probability that they are both the same color. What we need to do is we need to look into the branches and see which one is going to be the outcome, okay? So for this one, it's going to be yellow, and then we multiply each of these to work out yellow and yellow, yellow and blue, and then if we do this on the bottom, it will go blue to yellow, and then yellow to blue to blue, okay? For the same ones, we can see that it's these two and these two respectively, okay? So the probability of yellow, yellow, that's just going to be a third, because that's up here, times a quarter, which is this here, and that's equal to 1 over 12, okay? The probability of blue, blue, that's just going to be 2 and 3, which is here, times 3 and 4, which is here, multiply top, multiply bottom. We are left with an answer of 6 over 12. Now let's add them together, because remember, for each of them, they're going to be the same color. You agree with that? This is yellow and yellow. This is going to be blue and blue. So it's just going to be 1 over 12 plus 6 over 12, which is equal to 7 over 12. So let's put that in our final answer. Is this video making sense? No? Okay, join my Discord server down below and ask any questions you want for fast responses guaranteed. Now let's look at what we've done so far, but in an exam solution setting. Hannah's going to play a game of chess and a game of backgammon. The probability that she wins at chess is 0.6. The probability that she wins at backgammon is 0.7. So work out the probability that she will win exactly one game. Okay, so the first thing we want to do is draw a probability diagram. This is going to be for chess, and this is dub, and this is L. And then this one's going to be for backgammon. This is going to be a dub, and this is an L. This is a dub, and this is an L. Okay? So now let's work out the probabilities. We know that the probability that she'll win chess is 0.6, so let's put 0.6 there. What's the probability that she'll lose? The probability of chess loss is just going to be 1 minus 0.6, which is equal to 0.4. Okay? Now let's look for backgammon. We know the probability that she'll win is just going to be 0.7. So the probability of back loss is going to be 1 minus 0.7, which is equal to 0.3. And we can do that for both branches. So work out the probability that she wins exactly one of these games. Okay, what we can do is we can, again, use the probability. So if she wins chess, it means she then has to lose backgammon, right? And if she loses at chess, it means she has to win at backgammon. So let's work out the probabilities of each of those two events happening. So the probability of win-lose is going to be 0.6 times 0.3, which is equal to 0.18. And the probability of losing then winning is going to be 0.4 times 0.7, which is 0.28. Let's add them up together, and we are left with an answer of 0.56. No, 46. And that's our final answer. Thank you guys for watching. Do you want to pass your exams with flying colours? Well, get tutored by me. Drop me an email and we can organise a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.